Wait, what are we doing?
Homework. Notes.
We'll go through some examples here. So we did an example yesterday, found that going through the quadratic formula gave us the solutions. It gave us some nice algebra that worked out real nice and gave some real clean rational numbers as answers. I think they were like -2 and +3. Or might have been -3, +2. Some of our quadratic equations will not do that. So I want to see some of these. I want you guys to experience some of them so we know what to do. Okay? And I suggest that you have a calculator on hand. Probably going to want like Desmos. Yeah, I think that's going to be the best one to have on hand. Okay? So, this one here. And actually, let's go to... Let's see here. All right, so when we look at this one, there are other methods. You guys remember the AC method? Taking 2 times -3 and get -6. And then trying to figure out what two numbers multiply together to give me -6, but add to give me -7. You guys remember doing that? Okay. Are there any numbers that multiply together to give me -6, but add to give me -7? There are none that do that, right? Okay. So factoring using the AC method is impossible here. Okay. So right now, before the quadratic formula, we would write, this is prime. This is not factorable. Can't do anything. Okay. However, now that we have the quadratic formula, which is written as x equals the opposite of b, plus or minus b squared minus 4ac over 2a. And because that thing only incorporates a, b, and c, and in our problem we have a, b, and c, we should be able to solve this now, right? Just be able to substitute. Okay? The issue here, I think we're going to find out, is that the radical doesn't turn out to be a real nice number when we're done. Okay, so we're going to investigate this, talk about this a little bit. So, what is your A value in this problem? 2. What is B? -7. And C is -3. Okay, so now when I plug those things into my formula, x equals, so the opposite of B, so what would be the opposite of B here? +7. Okay. Then we got plus or minus. Okay. We'll have then -7 squared. That's B. So when I'm substituting inside this radical, I'm going to put everything that I substitute in parentheses so that I don't mess up signs later on. A was 2, and C was -3. And we'll put that over 2 times A. There are so many places that you can make a mistake in this. And I know people want to rush through and say, I'm just going to do this stuff in my head. I'm going to write down 49. I'm going to write down, plus 24 there. And do so. You just make mistakes doing that, with signs especially. So my suggestion, at least when you start the problem, just run through here and put in exactly these values. Don't try to evaluate in the first step. Write it down. And then in the next step, you can start attacking the evaluation. So now, what is -7 squared? 49. Okay. So now, the next thing you're going to do is look at these things. Okay, so I've got, and I'm going to multiply those together. So ultimately, it's -4 times 2. What's -4 times 2? -8. Then you take -8 and multiply it by -3. And what's that give you? +24. So I'm going to hit plus 24. And the bottom is going to be 2 times 2, which is 4. Okay, so now in the next step, I'm just going to add together the 49 and the 24. And that gives you 73. Okay, so every time I do one of these problems, and I think we could argue that I've done a lot more of these than you have, right? Okay. Done this for a lot longer than you have. I still, every single time, at least do those 3 kind of steps. Right. I simply, purely just substitute, and then I evaluate the radicand, the part underneath the radical, and then I simplify that. Okay. Now, here's where it gets tricky sometimes. Those are our 2 answers. Okay, 2 answers. So we said yesterday we can rewrite this as 7 plus radical 73 over 4. And down here we can write it as 7 minus radical 43 over 4. Okay, those are our 2 answers for x. Yesterday we didn't have numbers that were that ugly, right? It's a 73, not a 43. Yesterday, if you remember the question, that radical was 100 underneath. And 100 is what we call a perfect square, right? Meaning that I know that there's a number multiplied by itself that will give me 100. Anybody think of a number multiplied by itself that gives me 73?
0.
Huh? There isn't one because... Huh?
73 times 1.
Multiplied by itself. So, like 8 times 8, 8 times 8 is 64. 9 times 9 is 81. 73 falls between those 2, right? Between 64 and 81. So that means radical 73 must fall between 8 and 9. Does that make sense? So it's not, so radical 73 is not a rational number. Okay? It's an irrational number. So we cannot do anything with that. We leave that alone. Okay? Now, if I was working on my calculator, like Desmos, and this is where I want you to be cautious using Desmos, we said that we could say, I could type in the opposite of b plus the square root of b squared minus 4ac. You can either hit SQRT and it will put it in, or you hit this button right here. And we'll divide by 2a. Okay? So yesterday at the end of class I said, well, let a equal what your a was. So I think our a was 2, right? B was, for us, -7. And C was -3. And you see that it gives us 3.886 back, right? 0.000936. And what happens, I don't have a program that will show this, but that number should go on forever. And it should never repeat or terminate. That's an irrational because that radical 73. When they wiped their computers clean, they took my program that I was able to actually show that. I could show you something out to like 1,000,000 decimal places. And you would see that would not repeat. So, that is one of my answers. What answer? So if I go and type in the 2 answers that we found, didn't we say it was 7 plus the square root of 73, all divided by 4? Do you see how that number right there is indeed the same as that number? Does that make sense to everybody? But if you wanted to write this number, if you wanted your answer to be that, you have to round it. Does that make sense? Okay, because you cannot write all these numbers out. Okay, because they go on forever. So once you round that, even if you round it out to like 1,000,000 decimal places, it is not the exact answer. And that's a problem in some mathematical contexts. Okay? This is the exact answer. There is absolutely no rounding in the 7. There was absolutely no rounding in the 73. And there's absolutely no rounding in the 4. So that's an exact answer. Does that make sense? So we like to write it that way. All right. Now we also had the answer. Should be that, so we can put a minus sign in here. So we get negative 0.386. Okay, so those are the two answers that if I was just going to use my calculator that I would come up with. Okay, but these are the two answers that are exact, that are what Math Excel and of course exam, those types of things are going to ask for. Okay, so when you do this, you might have the idea, you might be able to evaluate this and get that 3.886 number. But then Math Excel is going to say, type it in as 7 plus radical 73 or 4. And if you don't know the algebra to get to that, obviously you're not going to get that question right. Does that make sense? Okay. Now there are other things that happen. We can simplify. So let me ask you this. Is 7 divided by 4 plus square root of 73, that divided by 4, does that give me the same point or 3.88 number? So what I want you guys to see here is that that and that are equivalent formats. So when I put this 4 right there, and I got a sum up top, it is equivalent to saying it's the 7 divided by that 4 plus the radical 73 over 4. Does that make sense? And that's what you guys know about common denominators, right? If I start with that bottom one, if I start with this bottom one, do they have a common denominator of 4? So I can then do the algebra at the top, right? And we can come into that. So doing this is kind of the separating of that common denominator. Now, the reason we might want to do this is if that number was an 8. If that was an 8, wouldn't that cancel and give me a 2 there? Does that make sense? So there might be some simplification that can happen here, and Math Excel is going to ask you to simplify things. Okay, so I want to make sure that we have those abilities. So I'm going to see a couple examples here. We'll see if we can generate something where we need to do that simplification. So let's go to this one. What do I need to do to this one before we can even start? Bring the 7 over. Okay, so it's going to be turned into 2x squared plus 9x plus 7. Okay, go ahead and identify your A, B, and C's. Because remember, we want one of the sides to turn into 0, right? So I want that side to become 0. So the only way I can make that side become 0 is if I add 7 there, right? So then I need to add 7 over here. And just because of the notation, like I'm not adding 7 underneath this 9x, but there's a plus 0. So maybe 2x squared plus 9x plus 0 equals negative 7. So add 7 to the right-hand side, and then add 7 to this side. So that's where that plus 7 comes up. Yep. You get 2, 9, and 7 for A, B, and C?
Yes.
And they're all positive, right? Okay. So then our formula, and I'll put this formula on the board on Friday. Or quiz on Friday. But I don't want the memorization of that formula to be the thing that throws you off on the questions that I asked with the quadratic formula. So now we just plug things in. So go ahead and take a minute and plug your values in for A, B, and C into the formula. So plugging everything in, we should get something that looks like that. Negative 9 plus or minus square root of 9 squared minus 4 times 2 times 7. All over 2 times 2, right? Okay. Now as we evaluate that, what's 9 squared? 81. What's 4 times 2? 8 times 7? 56. And then all over 4, right? What's 81 minus 56? 25. And that's all over 4, correct? Okay, so here's where we end up with a number underneath the radical. What kind of number is 25? Not a prime.
Perfect
It's
square.
odd. It's perfect square. Because there is some number that multiplied by itself will give me 25, right? What is that number? 5. So the square root of 25 is 5. So I can rewrite this as negative 9 plus or minus 5 over 4. Okay? So remember what that means to us. Negative 9 plus 5 divided by 4. And it means negative 9 minus 5 divided by 4. What's negative 9 plus 5? Negative 4. So negative 4 divided by 4 then is negative 1. Okay. Negative 9 minus 5 is negative 14, right? Divided by 4. Does 4 go into 14 evenly? Does not, right? What common factor do they have, though? 2. So I divide 14 by 2, divide 4 by 2, and I can simplify it that way. So those are my two x values. So remember what this means. Those are the two spots on my x-axis. If we were to look at those values on our x-axis, I'm going to look at negative 1 and negative, it was negative 7 halves, right? Yeah, negative 7 halves. Those are those two spots on your x-axis, right? You guys remember what that means for us in regards to the quadratic formula? If we were to take this original equation, 2x squared plus 9x plus 7. Do you see that graph then passes through those two values on the x-axis? Does that make sense? So those are those numbers that we're finding here, negative 1 and negative 7 halves, those are x-intercepts. Okay, that's where our graph is going to cross the x-axis. Okay. What about, and I know I've got some others here. Give me 1 second real quick. All right, let's cross this one out and replace it with x squared plus 4x plus 5 equals 0. I want you guys to run through, find A, B, and C, plug in, start evaluating, and then in about 3 minutes we'll come back together and see where we're all at. Just before you get too far, does everybody have that when we substitute? Negative 4 plus or minus square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. Okay. When you simplify underneath the radical, what's 4 squared the same as? 16. And 4 times 1 times 5 is 20, right? So we get 16 minus 20. What's 16 minus 20? Negative 4. Okay, so my hope is that we were able to get down to it, and this is where we would probably run into a roadblock. Okay, I'm going to circle that for now because there's really nothing I can do any further. Because here's my question. Remember what square root meant. The square root symbol is standing in for some other number that when I multiply it by itself 2 times, it gives me, in this case, negative 4. Are there 2 numbers you can multiply, or is there a number that you can multiply by itself twice so that it becomes just negative? No, because if I multiply something by itself, it's either a negative times a negative, which is a positive, right? Or a positive times a positive, which is also a positive. So what I'm saying here is that this thing right here is a number right now that we cannot deal with. In all actuality, it's a number that does not exist, and at one point never did exist. Okay? Until a guy, what's his name?
George Washington.
No.
Abraham Lincoln. Benjamin Franklin.
Oh wait, you're talking about that one guy. I know that one.
Who's Euler?
Euler.
Give me a quick second. I'm gonna double check.
I knew that.
You said Thomas Jefferson.
Oh my gosh, you know those little oh shoot.
I can eat a horse.
Inside out and it's like sad and happy. Or it's happy and looking good.
Regardless, what was happening is that this person was trying to solve the equation x squared plus 1 equals 0. Okay? And ultimately, you subtract 1 from both sides, you get x squared equals -1, right? And then he tried to take square root of -1, and he came into the problem and said, well, I can't do that. I can't take two numbers and multiply them together and get negative, or the same number multiplied together twice and get -1. So what he did was he invented a number. He called it I. Okay?
That's
And I stood for imaginary. Okay? Not like Austin's friends.
Oh, is that the like the icon thing?
Pirates.
Yes. So there's. It's called a complex number. Okay. When we incorporate I or imaginary numbers with this process. Basically, all I want us to know right now, because there's a whole field of mathematics that is dedicated to I and complex numbers. Basically, what I want you to know is that when there is a negative underneath this radical, okay, if you go back to what we talked about earlier yesterday, that thing is called the discriminant, the b squared minus 4ac. If it's negative, which is this last condition here, says it's less than 0, says you will have 0 real solutions. And remember, a solution is where we cross the x-axis. So if I have 0 solutions here, that means I have 0 places where I cross the x-axis. That means my graph does not have x-intercepts. Does that make sense? Okay, so the last question we did, we saw x-intercepts at like -7/2 and -1. If we were to graph x squared plus 4x plus 5, x squared plus 4x plus 5, do we see that that graph does not cross the x-axis? And the algebra that we did would confirm that for us, or verify that for us. Okay? So x-intercepts, finding x-intercepts, the reason for doing that, there's a lot of real-life applications, but one of the reasons is just to graph it, to find 2 points of the 3 that we need to graph a parabola. In this situation, finding x-intercepts would not yield us any knowledge, okay? So in this, if my goal is to graph x squared plus 4x plus 5, I'm going to have to find the vertex by taking opposite BO2a, which we've done. And then I'll have to choose an x value, like maybe -1, and plug it in, evaluate, get back 2, and plot that point right there, and then use the axis of symmetry to find that point over there. And that'll give me enough to graph the parabola with it. Okay? But x-intercepts on this one are not real. Okay? They're called non-real solutions in this case. Is it okay? All right. There's a lot, and we might, just depending on our time frame here, we might come back and talk a little bit more about complex numbers tomorrow and next week. We'll just see.
Here, listen.